All right, this is a video on enthalpy. This word enthalpy is right up there with my least favorite words to say in chemistry. Enthalpy, I just hate that word. But anyway, what the heck is enthalpy? So enthalpy is a measurement of heat energy that is either absorbed by an endothermic process or energy released from an exothermic process. Okay, so looking at enthalpy, we go back to our potential energy curves that we're familiar with now. So we're looking at a couple of energy curves for a exothermic and an endothermic curve here. Okay, so enthalpy is really just the amount of energy that has either been lost in an exothermic or gained in an endothermic. So it's just the difference between the starting and ending points of energy in a process that is exothermic or endothermic. So here we see that, the exothermic enthalpy here is, if our products, or excuse me, our starting point is up here somewhere by like 425, let's call that, kilojoules, and then down here it ends at something like 75 kilojoules. We would just take the difference between those two numbers, and that's the amount of energy that has been released in this process. And the same thing would be true here. Like this low energy system here that might start somewhere around 60 kilojoules, it absorbs, let's say something like up to 475 kilojoules. And so the difference between the starting and the ending energies is what we call enthalpy. Okay, and enthalpy has its own variable. It's called delta H, and that just means the change, that's the delta symbol, in enthalpy. Okay, the change in energy, that's delta H. And really just think of delta H as the amount of energy either released or absorbed in any exothermic or endothermic process. Okay, so along with this topic, which especially pertains to the exothermic stuff, we need to adjust what this curve looks like a little bit. Okay, so this is a concept that you need to be familiar with moving forward as well, and that's something called activation energy. Okay, and this is the energy required to initiate an exothermic chemical reaction. And activation energy is really important because exothermic reactions give off energy in the form of heat, light. We're talking about like explosions and stuff like that. And so you don't want that stuff to just happen without you wanting it to happen, right? So like think about a match, for example. A match is just like a stick that's got some chemicals smeared at the end of it, and in order for it to light, you actually have to strike it against a surface, and that's energy that you have to put into those chemicals to make them react, because you don't want those matches going off in your pocket, right? And so here's what a real exothermic reaction curve typically looks like. We have, I'll put this one up here to show you what we used to think of as an exothermic curve, where we start high and end low in terms of energy. And I want you to think for a minute about this being like a ramp that maybe a ball would roll down. And so think of this ball having relatively high potential energy up here at the top of the hill, and then with just the slightest little breeze here, this ball will start to roll down the hill. That's kind of reflecting the reaction taking place and the energy being lost. Okay, now sometimes you don't want that ball to just start rolling without you knowing it. And so in most exothermic reactions, there's this little hump in energy here. And so if we picture our ball as sitting right here, you can see that you've got to push on that ball quite a bit to get it up and over this hump before it then starts to roll down the hill. And so this little hump that is above the delta H line, that's known as the activation energy. So that might be the energy that is required to strike a match or something like that. Okay, so the only other thing to think about here is that delta H, or the enthalpy, is still just a difference between where the ball starts and where the ball would end, right? And we don't take into account the activation energy when we calculate a delta H. Okay? Now there is a activation energy associated with endothermic reactions as well, but we're not going to cover that. It's something that you'll probably cover as you move forward in more advanced classes, okay? So this is what a real exothermic curve really should look like. All right, hope that helps.